Du musst den Projektor einschalten. You have to turn on the machine. Okay, so let's get started. Welcome to the first session here at the IETF. So this is the TCPM meeting. So if you're not interested in TCPM or in TCP, this might not be the right working group for you. Before we get started, let me introduce Michael. So as you might have seen, we have a new co-chair, and I think this is the first time where Michael is chairing on site. So let's all welcome him. So next slide. Yeah, we still work on the name collision issue. So we think of a IANA registry or something. Yeah, so it's an unfortunate name collision. So we work on it. So this is the note well. So for those of you who are the first time at an IETF meeting, please read carefully the note well. For those of you who know it, you probably know it. So this is an IETF meeting, and everything that you say here is governed by the note well. Some logistics for this meeting. We have a note taker, as a Gori, more or less as usual. So thanks a lot to Gori for his volunteering for that. I will look myself at Jabber. If somebody else could look at Jabber, that would also help. But at least I will take care of it if nobody else does it. Whenever you go to the mic, please say your name. And it might be useful if you check afterwards in the Etherpad if we correctly spelled your name. If not, please correct it. So that's the easiest way to fix the minutes. And in general, whenever you submit an internet draft that is somehow related to what this working group does, that is more or less TCP, then please use the TCPM in your draft name. So next slide. So this time our agenda is not fully packed, so we have time for heated discussions this week. We will start as usual with the working group status, and then we have 3 working group items on the agenda. We will discuss the alternative backoff. We will discuss the accurate ECN, and last but not least, we will discuss the generalized ECN draft. And then we received requests for 2 individual presentations. The first one is the low latency option. So this is presented for the first time in TCPM. And then we decided to have another presentation on the 24/140 bis. As the agenda is not really full, we really have some time for discussion this meeting. Still, I mean, we will probably have to extend some of the slots a little bit because the request is a little bit short. But still, I ask some of the presenters to be quick, even if this is not quick. On the status of the documents, so we don't have any RFC, but we are working on getting there. So the data center TCP draft is at the moment in the final phase of addressing the IESG comments. So I think there was an update this morning, and we are getting close, I think, to adding all comments. So this one should get into the RFC editor queue relatively soon. We had a working group last call on Cubic, and there was an update, I think, last week. So at the moment, Yoshifumi is working on that. So the document shepherd on Cubic is Yoshifumi, and we will come back with the next steps once we've analyzed the new update. Then, as usual, our quick overview of the active working group documents. So the 3 ones that are shown on this slide here are all discussed in this session. So I will not comment too much on the alternative backoff, the accurate ECN, and the generalized ECN one. The Cubic one, as I have mentioned, has passed the working group last call, and we currently look into the new version. Other than that, we have a couple of working group items which are not presented here. On the REC one, I think there's ongoing experimentation, as we've not received any update on that one, but it was discussed quite a bit in the last meetings. On the 793 BIS, Wes is currently working on an update. So he actually told us that there will probably be an update this week. Unfortunately, Wes is not here, so he can't present it. But there should be an update this week. On RTO to consider, there is no news after the last meeting. And the same also applies on EDO. So I think Joe is not in office this week, so that's why he can't comment himself on EDO. And that's actually the status. So are there any comments, any questions on the state of affairs in TCPM? Okay, if there are no general comments, we would head on to the first presentation, and that's Naeem on the alternative backoff. And as usual, since this is Monday morning, please stay into this box there. I mean, this is your cage as presenter.
Okay, so
you can move the mic. Well, I thought about moving
the whole thing. Yeah. That's all right.
But don't leave the square. I mean.
Yeah, I'm in the square. Yeah. As long as I'm here, I'm gonna be fine. So this is an update on the alternative backoff with ECN, as we call it, APE. So we have submitted the version 01. So basically, the changes that in 01 compared to the version 0 is that we improved the text. We had lots of comments from Stuart Cheshire, and we incorporated all of those comments into the document. And also, we basically did some minor changes, including change to the reference that we made to the technical report that shows our results now is published. So then we referenced the published version, and also we kind of worked on sorting out the terminology throughout the document. So, for example, we always use the term AQM mechanisms. We also provided clarification on the intended purpose of the experiment. So what we mean by the experiment in this draft, since this draft is right now in the experimental status, basically all the changes there were basically the wordsmithing and clarifications. There were no major changes, so almost no changes to the technical contents of the slides, the draft. Then when it comes to implementation, we had some early FreeBSD implementation of it, which is a patch available online. This patch was brought up by Tom Jones from the University of Aberdeen and last week, and we have submitted this for the FreeBSD upstream and waiting for the results. Also, we've got patches available for Linux, and we are planning in the future to submit it to the Linux. So next, what we are trying to do, because this draft initially was focusing on TCP, and then we decided that we basically generalize it to the congestion control mechanisms that are window-based. There was a discussion right now, as the draft stands, is that it promises that it would do an SCTP, basically congestion control based on APE using the ECN. But what we are suggesting here is that we won't add the CTP APE support to the draft that we have. Rather, we provide the general guidance to say that basically we recommend that APE will be the part of the design of any transport protocol that implements the window-based reduction to ECN mark congestion. So basically that's the general statement that would be written in this draft instead of going to specifically SCTP-related stuff. And there's something happened there. So then, since SCTP's congestion control spec is not defined yet, we leave the detailing of the how to react to ECN to any future draft that basically defines the congestion response in SCTP, and just stay kind of generic in this draft about it. So that's basically the discussion that I would like to bring to this working group. And also, I have a question, and that is, should we address these two things? Is there anything else we should do so that this draft basically proceeds perhaps to the working group last call?
So Michael Jackson from the floor. I think taking out the SCTP stuff and just saying whenever SCTP has a specification for ECN, we'll take this into account is fine with me. The other comment is that in the description of what you are doing is you are assigning flight size to flight size n plus 1 is flight size times the factor, and I think you can't modify flight size since this is just the number of bytes which are outstanding and not QMAC. So you can't change this variable. You can observe it and use it, but not change it. I mean, what are you doing? If you have 1,000 bytes outstanding and now you say, oh, only 500, which 500 are you revoking to have ever sent? That doesn't make sense.
So this was a long history of, initially it was looking at the CVIN, and then in the IETF there was somebody saying that, oh, this has to be flight size, then we changed it to the flight size.
Well, you can change it to window, you can change it to how you update it, but it's definitely not the flight size, because the flight size is the number of bytes you've sent, and you have not cum-act. So nothing you can have on the left side of an equation or an assignment.
So is there any parameter you recommend to use there? I would go with CVIN if it was only
that's fine with me.
If somebody else in the IETF hadn't said that, you should definitely be using flight size.
The RFC had the congestion control RFC defines flight size.
No, not for SCTP.
Pardon?
SCTP.
No. TCP congestion control RFC defines flight size as something being the bytes which have been sent but not cum-act, and you can't have that on the left side of an assignment. Changing the
It
CVIN?
uses the CVIN, yeah.
I looked at the patch.
It's available online.
So changing that.
That's a minor thing to change. I mean,
Yeah, I mean,
the text,
it's an editorial change, right? But these two things
I agree.
should be changed.
Okay, so I think it's clear that an update of the document is needed, but still for as our educational purpose, could we have a show of hands how many have read this document recently? Because we definitely look forward to reviews of this document. So can you give me a show of hands how many have read this document? So I see of the order of 5 people. Yeah, I would say 5, 6, something like that. So, yeah, who is willing? So okay, better question. So, who is willing to review the current or the next version? Okay, I see Dave. I see Ronald.
Randy, Lawrence.
Yeah. Okay. I think we have enough reviewers.
Note them down.
For the note taker, can you please write down the persons?
So I think from a process perspective, we have to await with this document until the ECN experimentation has passed through TSUWG. But if this is happening soon, and if you have enough reviews here, I think we can move this document forward.
David Black, editor of the TSVWG ECN experimentation draft. That draft's basically through its completed working group last call. As will be discussed tomorrow, we've figured out what to do in that draft about the one remaining open issue, and we're going to talk about it here. So that draft is basically through TSVWG, should be going to IETF last call in the near future.
Okay, so then I think we're done. We hope really that we get some reviews on that, and we noted down the names. So if we don't see them, we will get back to the people. And as I said, then hopefully maybe in the next meeting or something like that, we think about last call.
Thank you.
Okay, so the next one is accurate ECN. So I'm not sure who will present this, so Bob or...
Hi, I'm Bob Briscoe, the co-authors. This one was adopted about 18 months ago. Been some major changes, carry on, yep. Just a quick recap of what it is, or what the problem is trying to solve is. Am I near enough the mic without coming out the box? Yep.
You can move that physical thing, yeah.
Right, so explicit congestion notification, just for those of you who don't know, there's a table on it there. The problem was that when ECN was added to IP and TCP, both in the same document, it only allowed one TCP feedback per round trip time of an ECN mark. So if there were many, it only allowed one, and sort of experience since then has shown that with that more information, you can do a lot better, particularly on latency. But at the time, we only had a TCP that reacted once, so there was only one feedback. And the way it worked is, for reliability, it set the ECE flag in the TCP header repeatedly until the sender set the CWR flag. So it was like, however many you had, you only saw one of them because of this repetition, right? So this is the idea is to change the TCP wire protocol to change the ECN feedback, and instead of using them as flags, use the 3 bits, which are only used when you're doing capability negotiation at the handshake. But once the handshake's finished, use it as a 3-bit counter field and just repeat a counter in there. And every time the counter of the number of marks you've seen increments, then eventually the sender will realize that it's updated, even if there's been some drops of ACKs, because the problem is that you've got no reliable delivery of pure ACKs in TCP. So you need some other reliable way of getting your congestion notification back. Then obviously a 3-bit field is a bit limited, but that's all you can get through middle boxes, we've discovered from measurements. So there is a option as well that gives you the information in bytes, not packets, and you know that will supplement the this revolving counter in the ACE field if you've got it, but it should work even if you haven't. Where work is, you know, it doesn't. You can get cases where you get a string of pure ACK losses where it gets confused because of the wrap, unless you have the option to give you more information. But you need quite a long string, right? Okay. Just to explain where it fits, and I've been told that this diagram doesn't help anyway, but so it's in text as well. So first thing is that accurate ECN has to be agreed by both ends because it's changed the wire protocol, right? So what I've done is split in the diagram, I've split the layers between the wire protocol in the transport layer and the congestion control. And accurate ECN is essentially an extension to the feedback wire protocol. So it does all the things the previous ones did as well. It doesn't, you don't need the other ones. This is like not a fork in the design. It's just an extension. Yeah. And you could use accurate ECN for BBR as well as for other protocols that need more information than once per round trip time, like TCP Prague that we're working on. And I believe, is Yu Chung here? I haven't seen him. He mentioned that he's interested in when he adds ECN to BBR to jump straight to accurate ECN and not go through the old feedback mechanism. So, and yes, for DC-TCP, accurate ECN also gives you benefits that we talked about years ago and we don't need to go through again. Right, so that's where it all fits. I did this because one or two people, particularly Stuart, were saying, can you give me a roadmap of where all these bits of ECN fit? As I say, it's not clear that this helps, but it might do. I guess what it does do, the next talk I'm giving is about a draft that's got the file name generalized ECN, but we've now decided to call it ECN++. And that also fits in this. It's a change to the sender, depending on what things it sets in the IP ECN field, but it only applies in the TCP context. These are all basically updates to the TCP way of doing ECN, which was a sort of missed out on the experience that all the other protocols got from it, and they did it right, whereas TCP has sort of got behind because it had all these problems with it. So there's all these bits need to be added to it to make it work, or make it work well. Right, so once you've got the feedback in accurate ECN, then you can have sender-based changes on top of it. Sender-based congestion control changes or sender-based setting of more ECN in the IP layer. Okay? Right, so the next few slides go through technical things we've updated in the last cycle or few, actually, because we haven't talked about this for some time. In response to a number of reviews we've had and our own thinking and experience. One of the big problems with ECN as it stands is that if there's bleaching of the ECN field, which means wiping it to zero, and that we'll talk about a bit later in this IETF, we've found it's quite common in mobile networks. We think it's a bug related to bleaching of the diff-serve code point, right? And so the problem with RSC3168, it has no way of even detecting that. It doesn't detect that, let alone any way to feed back that it's happened. And so there can be some really dangerous situations. For instance, your home router has a 3G or 4G dongle in it, or and so you've got, say, FQCODL in that's ECN marking packets, and then those ECN marks get wiped, and so both ends think they're talking ECN, but this thing essentially just pushes the queue right through to tail drop until it does anything. So you get this sort of oscillation between ignoring ECN and then tail drop going on. In accurate ECN, the feedback on the SYN and SYN-ACK, we are proposing to replace what was just feedback of whether it was CE or not with feedback of exactly which ECT there was there as well. Sorry, David, do you want to?
Hang on a minute, Bob, I'm confused. Yep. Suppose I've got something in the uplink that's uniformly bleaching the ECN bits to zero.
Yep.
How on earth do I get TCP to think ECN's working in the first place if that's happening?
Because you're doing that at the transport layer. This is bleaching IP.
No. Right, at the IP layer, I've got to set ECT in the SYN and ACK. And if those get bleached,
No. The ECN negotiation is in TCP, irrespective of what's set in the IP
I'll double
layer.
check this.
I think you wrote the RFC. So, I'm pretty sure I'm right, David.
I know you
Yeah.
right.
Right. Yeah. So we're proposing that we have 4 possible states on the feedback of the SYN and the SYN-ACK, so we can that both ends know what is getting through and what isn't getting through, based on that 2-bit field in the IP header, right? And we've got just that many spare states in those 3 flags, given all the previous uses they've had for negotiation and all the broken implementations there are and all the rest of it. So we've just got enough space to do this, right? And we've had a bit of discussion on that, so I think we'll move on while David thinks about that. Right, so the next point that's been raised, particularly by Praveen, who's not here, from Microsoft, is he's unsure about whether he wants to implement the accurate ECN option. He wants to know, can he just do the ACE field part of it, the essential part of it, and not the optional part? And the spec actually allows him to do that, but it's sort of, please don't. That wasn't the intention. In other words, the spec says you must not put the option on the SYN because it's not necessary, because the flags implicitly say you're going to support the option. Okay, thanks, David. David just said I'm right, by the way, for the record. Then on the 3-way handshake, there's a should and a should for the option, and on the first data packet there's a should, because the ACK before it isn't delivered reliably. So this is just to test whether the option's getting through, right? And then after that, once established, it's all you only need to put it on if it's change triggered, and even then it's optional because SAC takes precedence because drops are more important than ECN, right? So the upshot of all that is there's no musts there. There's only shoulds, optionals, and must nots, which means essentially Praveen would not have to put this option on. However, it does say that you must implement it and you must try to use it, right? Because the idea is that it's useful, and this isn't meant to be a get out for an implementer just to do less work, right? Next. Is there a question? Sorry. Did you have a question?
Were you sneaking feedback about this, or was this just informational?
I'm just telling people. Yeah, I suppose I hadn't imagined that people might want to discuss that, but people
so,
do.
Yeah. So maybe just add one more point. So originally we thought also you can use this, for example, for data centers where you might know what your setup is and you might know that you don't need the option. But for example, if you specify some kind of mechanism that wants to use the accurate information and really, really needs the option, you can specify in that document that it should activate the option.
Yeah. And that example you gave in a data center, if you think, oh, I don't need this option, you may well find that if you get long strings of loss due to incast, then your counters do get out of sync. And you do need this option as supplementary information to deal with wrap of that 3-bit field. Yeah, because the 3-bit field isn't much to get wrap on, especially with large windows. Right. Now coming on to the subject that's got the process wonks going for the last few months. We need to use the flag to the left there, marked AE, that's currently the nonce flag for this negotiation that you just saw, and also for this 3-bit counting field. And the nonce, as we've just been explaining, David's ECN experimentation draft, as well as enabling ABE, and enabling the next talk also makes the ECN nonce historic. And what we've agreed to do, there's two IANA processes needed there. One is to unassign the nonce flag from the TCP header in David's draft, which is more about relaxing requirements, because the registry for this is a process problem. The registry policy requires a proposed standard RFC to change it, right? And then the accurate ECN draft, we're in thinking it's likely to be experimental, but we are going to assign that flag from a registry with a policy saying it has to be a proposed standard RFC, but we're going to, or Mia's going to raise an exception, or Spencer's going to raise an exception and say there's a good reason for this. It used to have an experimental RFC on it. We're now going to try another experiment on it. Right? So that's all.
We will have some discussion after this regarding this procedure thing.
Okay.
So just go on.
You mean after the talk?
After the talk,
Yeah,
just go on.
Yeah. Can I just check I've got all the points on there?
I think you are.
Yeah, I think that's about it. So the status is it's implemented in Linux, Mia's implementation. The URL is there. We've been waiting for this flag to become available officially before it can go any further. We were also waiting for ECN++ to be adopted, which is my next talk, or actually Marcelo's next talk. We're co-authors. Because there's some things that Accurate ECN allows ECN++ to do better, but you couldn't really refer to it when it wasn't even adopted. And then finally, we've got a few pieces I want to open up for discussion in appendices at the moment in the draft. The first one is what I've just been talking about, feeding back 4 code points on the SYN and the SYN-ACK. On the SYN. The 4 code points that were on the SYN, feed them back in the SYN-ACK. And Open Design Alternative B is about feeding back all 4 ECN code points that were on the SYN-ACK in the first ACK. Yeah, so the SYN goes that way. You have to feed back what was in the IP header back in the TCP header. Then the SYN on the IP header in the SYN-ACK, you have to feed back in the TCP header what it was. Do you see what I mean? So you go up one layer at each way of the handshake. That second point is a bit more difficult because the first ACK is not delivered reliably. So if you're trying to use this as a fallback mechanism and some middle box doesn't like it and drops it, you've got no way to detect that the third ACK of the handshake has been dropped. And so what we say in the draft is that assuming you have some data coming from the client, because you don't have to, you repeat that on the first data, but then we also have to say that the other end only looks at it if it's the first one arriving. So I think we've sorted out the problem. If there's any discussion needed on that, or if anyone's read the draft and doesn't like that, we'd certainly like people to look at that, some TCP expertise to look at that to check that we haven't forgot any cases. I don't know, simultaneous opens and things like that. We have thought about all that, but maybe not in all the possible cases. All right. Now there's the open issues. I wanted to ask people about, particularly the data center people here. At the moment, we have had a little discussion on this before. At the moment, we only send the accurate ECN option on when a different ECN code point changes. So if the counter is continually updating, you're getting lots of ECT0, you don't have to send an accurate ECN option unless you get a CE. So it's like when something happens, you have to send an accurate ECN option. That's what we call change triggered. Now that means that potentially if you've say got alternating ECN marking, you get a lot more ACKs than if you've got constant ECN marking, and so that alters the rate at which you're the rate of your acts through your data center, depending on the traffic. I see Andrew shaking his head here. He might not like that because you're getting all these small packets at certain times and not at other times. Right? Is that a problem? Because what we'd like to do is make that a must, because if you don't make it a must, you can't rely on the timing information, because you don't know whether the other end's doing it all the time or not. So we've made it a should at the moment because we know there's a concern about it.
Yeah, and I think a reasonable option there is if the RTT is very small, and so you can't trust the timing information anyway because you're beating your timers, just...
But the receiver doesn't know what the sender's time resolution is.
Sure, but it knows what its own time resolution is.
Yeah.
See, the thing is, producing that many acts is going to cause problems for both stacks in a very short RTT high bandwidth environment, just because you're constructing more packets and you've got to go around that loop so many more times.
Right. Yeah. Okay.
And also the switches themselves, the average size of a packet in the network matters, and acts are small, so you're pushing it downward and reducing PPS capability.
I know all these problems. Yeah.
Yeah. On longer RTT connections, not a problem. I see no problem with doing this halfway around the world, or to anything that's not physically in the same building. But across the data center fabric, it's likely to break things. But then, traffic across the data center fabric is special case because you know where the destination is anyway. So,
yeah.
Just maybe a note to say it's okay to do that if you know for sure that the destination is inside the building. Yeah, something like that.
Okay, so maybe we could put together some sort of. I'm more concerned that we put together something so that the thing that's receiving this feedback can know for sure when it can rely on the timing information of the acts.
Yes.
So it needs to be something deterministic.
Yes.
Not just sort of if the round trip time's a bit bigger,
Yeah, or else have the receiver mark that it did this.
Yeah, I have argued for an extra bit to say whether you're doing this or not, but we haven't really, that's just awkward. We haven't really got a bit.
Yeah, I understand.
Yeah. We have got an option. Actually, one possibility is we did consider the possibility of the initial number you put in the option to start the counter. We can put different numbers in depending on what your mode is, if you like. We could do that, maybe. Mia?
Mia Clivin. So I'm not convinced that we really need it, because if you put a should in, and most of the implementation do it, then you can just make a stronger assumption that it's done that way. And also you can probably detect that it's not done that way if you just, see every second packet act and nothing changes ever. And timing information is anyway that fuzzy, so it's anyway not very precise. So I'm not seeing a strong need for doing it. I mean, I understand your point that if we don't do it now, it will be too late and we cannot change it in future. But I'm also not convinced that we need any additional complexity.
The other thing is about this, that the time when you most want this timing information is right at the start of your flow, when you're doing your slow start or whatever. You want to know, and that's sort of not enough time to heuristically check what the other end's doing.
When you start a flow, you usually egg every packet anyway.
Usually, yeah. Yeah.
Yes, and so
State your name.
Oh, sorry, Andrew McGregor again. If the receiver transitions into doing a compression later in the flow, then it's not very harmful. And actually, having accurate timing information during slow start, even on a 15 microsecond RTT, is possibly useful.
Yes. Yeah. Yeah. Okay. So maybe we can say, if you're not going to do it, make sure you do it during slow start or something like that. Even though the receiver doesn't strictly know when slow start ends, it sort of vaguely knows.
So
Okay.
I would like to limit the discussion right now for everything except for the assignment of the NS.
Before we go there,
Okay.
to the fun part. As a one comment, Michael speaking from the individual. Mike, I read some statements in the document on the TCPM consensus.
Okay.
And my recommendation to the authors is to review that, because there are some statements on the success criteria of that experiment which I find a bit surprising. So to me, an experiment.
Can you remind me what they were, because I can't remember?
The wording is the success criteria for the experiment is that the TCPM working group deems the protocol stable or something like that.
Okay.
And let's be clear, the success criteria for everything that we do here is getting things deployed in the internet, getting it running. It's not the working group thinking about...
Well, no. Okay, so maybe it's an implication needs to be made explicit that it's been deployed and the working group considers it stable.
To be honest, I think the working group consensus doesn't matter, because if it's getting deployed and things like this, we will anyway publish a PS. So I think the purpose of the experiment is implementation, that getting feedback, improving it, whatever.
Yeah. Okay.
I don't see why this document has to make a success criteria that talks about the TCPM working group and the consensus here. I don't see why that's needed.
Well, if it's going to go to PS, the TCPM working group has to agree that it...
Yes, exactly. Yeah. But you don't have to write it in this document, okay, because it's obvious.
Yeah. Right.
Any other questions, comments, not related to the bit?
So nothing further on the nonce process, that's done. Yeah, good.
No, I have a slide for that.
Oh, okay. Now, or should I stay here, or?
You can stay there. So if there's no other comments, then we move to that. So that's a procedural thing. And in an earlier version of Bob's slides, there were some alternatives listed. So we had a discussion with the working group chairs of TSWG and the ADs about how to deal with this reassignment. So it was agreed that in TSVWG, the unassignment of the NS bit is triggered. So that's agreed. And so the open question, I mean, not the open question, but what had to be discussed was the reassignment. And there were a couple of options. The first option is that it is assigned within the TCPM working group by the accurate ECN document. There are three variants of that. The first one is the document itself is heading for experimental status, and the registry for these bits requires a standards track document. So that's why an AD has to be involved to say this is okay, and it was indicated that that's a possibility. The other one is that the document is not going for experimental but for proposed standard, so then we don't have that problem. The third one is that the for that registration, the procedure for that registry, the registration procedure is changed. So currently it requires a standards track document, so you can change that to something that requires only an RFC or something like that. However, the registry covers 6 bits. So you would change it for not only for the 3 which are now currently assigned, but also for the 3 being unassigned. So this is also a drawback. And another variant of the third option is to have to change the policy only for the NS bit. But that would mean you have to add a registry for 1 bit, so it's also getting very ugly. Another possibility is that it is assigned in a TSVWG document with or without, so in 2 variants. However, the chairs of that working group indicated strongly that they don't want to do it in that working group. And I mean, we're just checking if there are any other possibilities. So one generic possibility would be to have a proposed standard document assigning assigning this document, assigning this bit, and then saying whenever an experiment wants to use it, it has to negotiate by itself that it's being used, and then it can use this bit for whatever experiment it wants to use. This is a generic solution, but doesn't fit into the current way of the accurate ECN document. So these are the options we are aware of. Are any other options? We have I mean, if you look at this, I mean, you can.
Just because I'm standing here, like, so an option is to not do accurate ECN, but I guess that's not an option.
True, that's an option, but I missed that.
I got to.
That's not a technical comment, by
the way. So
I just want to ask or point out that we really need to be thinking: are there any problems with the one that the working group chairs and ADs are happy with, and otherwise we don't need any other options?
No.
Yeah.
I just we talked about this, and we just wanted to make it transparent for the working group why the result of the discussion was use 1A, which is everyone is fine with it, and all the other solutions have some other drawbacks.
Well, I could describe the drawback with 1A if you want. Which is, shall I do it now? Do you mind? Go on then. Yeah.
Mia Kulevit. So there's actually one more option. One is we don't assign it right now. Leave it open until the experiment is closed and then assign it as soon as we have a proposed standard. But I think the reason why we have the registry is because we want to use this as a mechanism to make people aware that this experiment is happening. So I think the outcome should be that the RFC number for this experiment should be mentioned in the registry.
Gori wants to say something?
Hi, Gori Fairhurst. I had trouble getting out of my place where I was sitting, and by the time I got here, someone had already said it all. But 1A was what we suggested. I could ask another question while we're on silly questions. It was from a conversation with the man behind me, but the NS field appears in textbooks and on some people's web pages like mine.
Yeah.
It might be nice to keep it called NS and rename it, because that diagram is exceedingly well distributed, where you see the header fields of the TCP header.
So changing something else it means, but still call it NS.
So changing the semantics.
How about
by keeping the same
network
name?
Signal?
So I just want to back what Gori said. So I mean, the TCP header is well documented in many documents outside the IETF. And while it's clear that we want to have this experiment here, it's still an experiment. And I'm a little bit concerned about outdating every single textbook that is written on TCP by an experiment. And as I said, there might be ways to deal with this, and one way might be to use another name for that bit, or somewhere else. But I'm a little bit concerned, not about the experiment, but the impact this experiment has on all textbooks out there. And there are good reasons why that flag is actually standard. But in that specific case, it's a figure that everybody sees. And the textbook gets outdated in other ways, we know that. But in that specific case, it's the first figure in the textbook that gets outdated. And as I said, I think we should think about that. We certainly don't want to prevent that experiment, but maybe let's think about, for example, how we name the bit.
Michael Jackson from the floor. So personally, I think it's better to make clear that the diagram is outdated because you see it, so you name the flag differently. But compared to stick with the acronym, but the semantic has changed completely. So people think it hasn't changed, but it did change.
Yeah.
So break it as soon as possible.
I'd agree with that. Yeah.
So, I mean, if this is your main concern, then the bit shouldn't have been assigned in the first place to an experimental draft. But like that was done, so we cannot change this part anymore. So I take the action item to update the German Wikipedia page.
Gori's picture of the header comes second on Google. So.
David Black, a not completely flippant suggestion. We could change the bit name to not specified.
Lars, to me, the most important thing is the first bullet, right? The unassignment. I don't actually care about any of the rest, right? Because in the good old tradition of squatting on code points, by the time you get so successful that we will need to deal with this, we will deal with it. So it seems like we're doing a lot of thinking here. I mean, leave it unassigned, use it for the experiment, and if it's successful, we will know what we need to do, right?
So just to clarify, so what you say is when the experiment document, publish an experimental RFC, once it's successful, progress it possibly to PS, and then assign the bit? Okay.
Mia Kuhlmann. So I don't think that's the worst option. We discussed that, and we thought if we have the registry, it should also reflect what the current state is. That's why we were rather in favor of assigning it. But that leads to another option. We could also remove the whole registry.
Okay.
So I think, between the small group we had yesterday, we kind of agreed to go for option A or C, where A is the default we can do right now, and C is something the working group could decide on.
Can I comment on Lars's point? Given this negotiates a new feedback protocol for TCP, I think it'd be really bad if we allowed other experiments at the same time with that bit, so that your negotiation, you think something's happening and it's not.
Lars, an IANA registration doesn't stop any of that.
No, but it helps.
No, it doesn't.
Oh, yes, it does. It does.
How?
It does not help the bad people, but it helps the good people.
So, yeah, the amount of good people that will actually look at an IANA registry before they do anything is probably the people in this room, and probably not all of us.
No, so, that's not true. That's not true. I don't think we should not do something that's correct just because there's a lot of incorrect people,
So this is Michael, that's individual contributor. I've seen a lot of vendors squatting on code points no matter what Jana said. So whether we register with Jana or not, that doesn't matter to those implementers that squat on code points. Of course, we can agree that it's the right thing to do, but thinking of bad implementers is a non-concern in that conversation, in my opinion.
Yeah. Can I say what the problem is with A? Just in that it essentially is a circular dependency with that if the ISG don't agree it, because we're assuming they will agree this process exception. If they don't, then there are two experiments in the ECN experimentation draft that depend on accurate ECN, and that will have gone through, and then the ISG throw this back at us and say, well, you can't have accurate ECN yet, or whatever.
David Black, Bob, I think you're way off into the hypothetical.
Well, it is hypothetical, but
I think you're way off.
The point is, the ISG do have to.
If the ISG does that, ECN experimentation bounces back to the TSVWG with the on-fire process with the on-fire process flag set, and we'll sort it out.
No. I'm not saying if the ISG don't approve ECN experimentation. I'm saying if they don't approve the process exception that comes later with accurate ECN.
Mia Kuhlmann, as a member of the IESG, I don't think that's a real concern. And even if that happens, then we just publish the document without the assignment, and then it's unassigned. And then we can think about it later. It's really nothing to worry about right now.
I was just explaining to everyone what the problem is and why we might need other options. But I don't think I'm happy with A. I'm just explaining to everyone there's two branches in a flow diagram when something needs approval. yes and no. Okay. We done?
So could we ask for feedback in the room about if you think it is good to assign this bit for the experiment?
I mean, there are different ways how we can assign the bits, so that's clear. But I think the first question where we'd like to get a feedback from the room is whether for this experiment there would be value in assigning it in the IANA registry by one way or another. It could be the 1A option or maybe something else. But as the key thing that we have to know first is there if the working group believes that we should assign it. And my proposal would be to have a hum on that one with two options. First of all, yeah.
Lars, just want to go back to the first bullet. So I assume we're all clear that that's what we're going to do, right? Unassigning is...
Yeah, sure.
Okay, unassigning is off. All right, we're good. We all want to do that. Perfect. Good.
Yeah.
Just want to state that.
Yeah. No, as we are only talking about the second step here, as whether we reassign this bit for the accurate ECN experiment. And as I said, my proposal is to hum on that with two options. Also, the first option is that we figure out a process to assign it again to the accurate ECN. The second option is probably what Lars proposed, that we keep it unassigned for the moment.
Yeah, Lars, and so I'm probably gonna hum for letting it be unassigned, but I do think we should do the experiment, right? So this is not a hum against the accurate ECN experiment.
Okay. Let's be clear. I mean, this document will move forward in TCPM no matter what the outcome of the hum
I just want to clarify because I'm thinking I'm going to be only humming, so it's going to be awkward.
But we all know who it is.
We know you're the white.
Okay, so I think are the two options clear to the room? So the first hum is whether you believe that we should assign it to this experiment. So if you think that that's the right thing to do, please hum now. And so for the note taker, this was a decent hum. The second option is if you believe that we should keep this bit unassigned for the moment and still continue the experiment, then please hum now. Also for the note taker, this were probably two persons.
I took the protocol. I had a mic, but I stood away from it.
I think, there's a relatively clear consensus in the room towards assigning it. It's not unanimous, but there's a certain consensus in the room. So we will figure out the next steps, but at least the feedback from the room is okay to figure out the next steps.
Next presentation.
Actually, while Marcelo's coming up, this is Bob Briscoe. As Mia pointed out, the last time this was presented, I've been trying to get this done since 2005. that flag. That's 12 years.
Hi, I'm Marcelo Bañulo, and I'm going to present our draft, our latest version of the draft regarding adding ECN support to TCP congestion, to TCP control packets, sorry. So, currently, RFC 3168 prevents from ECT marking the TCP control packets and the retransmissions. Actually, for CNACs, RFC 5562 actually allow marking the SYNAC, right, with some so-called ECN plus try once approach. What we're doing in this draft, in this document, is to enable the marking of all control packets and also retransmission. Enable the marking, ECT marking of all control packets and retransmission. So what we do in the draft is we do two things. We specify how this gets done, and we go through all the arguments that that are presented originally in 3168, and we try to deal with them. Okay. So we have several revisions of this draft. We have several very thorough reviews from media, from David Black, from Gori, and from Padma. Thank you very much for these reviews. Actually, they were very helpful and very detailed. Actually, they provided a very good excuse for my co-author to completely rewrite the draft. So now we have this new version. And it was recently adopted as a working group item. So I will, please, next. I will describe what the current situation is. So why are we doing this? Well, actually, not enabling marking of the TCP control packets results in performance penalties. Right? This has been reported in different scenarios, especially when you have a high amount of marking. Then these control packets tend to get lost. I mean, the probability of getting dropping them is much higher because the other packets are getting marked, and that actually results in performance penalty. Basically, what you have there in this graph is a flow completion time graph, and you see that those packets there that takes those flows there that takes about 1 second to complete, a bit more than a second to complete. This is a log scale. Right, it's basically because the scene got lost, right, and this is 1 second timeout that it takes for the scene to be resent, right. So actually, you see that actually getting the scene lost actually harms performance severely, right. So basically, what we're trying to do is so we mark these packets, so they are likely to get marked before getting lost. Hence, the performance will improve. Next slide, please. So. What we are doing here is basically enabling the marking of these packets. So we have two flavors of ECN feedback, accurate ECN and 3168 feedback. We really don't know which is the sender when we start the connection, right? And what we are defining what we're currently defining in the draft is that you can set the ECT marking in all packets, in all control packets and retransmissions for when you know that when you try the accurate ECN protocol, basically when you try the accurate ECN scene and after the accurate ECN has been negotiated. And when you're not sending accurate ECN, when you're sending 3168 scene in order to negotiate ECN, at that point you should not mark the ECT, but you can actually use mark all the rest of the packets. The reason for that is because accurate ECN already incorporates the means to feedback the echo if congestion has occurred in the scene, but it's very hard to accommodate that if you have a 3168 receiver on the other end. Right? So for this reason, we're only proposing to support ECT marking of the scenes when you're trying to negotiate accurate ECN. Okay, so that's the current state. Thanks. Next. So now I'm going to go through each of the different types of packets and explain you what the situation is, what is the approach that we're proposing. So when we're sending the scene, the problem is that we don't know if the other end actually supports accurate ECN, in particular if it supports ECN++, the marking of the packet, the ECT marking of the scene packet. Right, so if it supports accurate ECN, it's great because you get the C echo back, right, in case it was marked. The problem is what happens if when you send the scene, you get a reply that it doesn't support accurate ECN. So it may happen that the scene got CE marked or it didn't, right? So what do you do at that point? So what we're proposing to do is, in that case, we conservatively reduce the initial window to 1. Right, we assume that it was marked, okay? And we optionally cache the fact that this was marked, that the server doesn't support accurate ECN, right? So we don't try it again. This actually puts you in the position that if you try to use this, if there is a large number of servers that does support this, you get worse performance because you get the penalty of reducing the initial window, even though it wasn't a mark, which is the most likely scenario, right? So there are two arguments why we still think that's the right thing to do. The first is because you cache, so you only suffer this once. And the second is actually feedback provided by Yu Chung, that is that usually the client actually doesn't really need a big window in the initial. Who really needs a big window is the server, right? So to send a GET with one packet, you're good enough, right? So it's not that you will hurt your performance in large number of cases severely. So that's why we are proposing this. Okay. Next. Okay. So as I said before, the ECT marking in CNACs was already defined in ECN Plus in the 5562. However, what it's in there, it's really weird, actually. So actually, the behavior described in there, it's actually some attempt to completely mimic what will happen if the packet gets lost, right? So basically, if you get if you get a CE mark in the CNAC, what 5562 says that you should do is you should reduce the initial window, but also you should resend once a second CNAC without the ECT marking, right? So that actually we find that is very weird. And sorry, it's a 5-way handshake, yes, right? So actually we don't think that's the way to go. Actually, we think it's probably by simply reducing the initial window, you should be fine, right? I mean, you got the CNAC, there was a mark on the CNAC, just react to congestion and go on with it. Actually, we did some measurements. We tried the 500K top Alexa servers. There are a few of them that actually support CNAC, ECT marking in the CNAC. None of them actually does what 5562 specifies, okay? So that doesn't, as far as we can tell, nobody's doing that, right? So what we're suggesting is to actually update 5562. If needed, that's a procedural thing that needs to be discussed, whether this document should update 5562. But actually what we're suggesting is that the support for the ECT marking on the CNAC should be this, right? Simply reduce the congestion window and that's it. Next. So the other thing is we're suggesting that, we're proposing that you should be able to ECT mark the ACKs, the pure ACKs, right? So RFC 3168 doesn't actually specify what the receiver that receives a CE marked pure ACK needs to do. So the thing is that it is possible that they actually doesn't send the CE echo back, right? So this is a comment from media. So the question is whether we should enable ECT marking of pure ACKs, given that there may be some unresponsive receivers of that. Basically, that the receiver may receive the pure ACK marked with CE and do not send the echo back. I understand that was your argument.
The comment was because it's actually not a problem to lose an egg. Eggs are not sent for every packet. If you lose one, there's no penalty there, other than for the SYN. So you don't have to take the risk.
Sorry, can you repeat?
If you don't mark your eggs, if you negotiate the classic ECN, not accurate ECN, and you don't mark your eggs, and you lose some eggs because they're not marked, and so there's loss, there's congestion, and they get lost, it doesn't cause you any performance penalty.
What do you mean? If it was the last ACK?
Yeah.
it does cause you,
or less performance penalty, yes.
So again, if I mean, the thing is, again, what I think we probably need, actually, that I think I have this data, but I actually didn't process it, is to find out whether current deployed servers do actually send echo back from pure AX marks with ECT, right? So that's an easy test to do, right? I mean, you only need to send pure AX marked with CE and see what you get back, right? That should be possible to do and learn something, no?
I mean, that's for sure useful to do. It's just like the general concern when you mark a packet and you don't have any feedback about if it was marked or not. That's actually something we don't recommend in general. But yeah,
I agree. Okay, so this is something that we need to figure out. I'm happy to try to provide some data about what I'm able to find about this, and based on that we can figure out what to do. Okay, the current recommendation is if you receive that you should mark ECT mark the pure AX, and if you receive echo of a CE mark in a pure AX, you should react to it. You should reduce your congestion window appropriately, and eventually you could employ the JANA's congestion control on AX if you think that's useful. You're the author of that, right? Don't do that. Okay.
There's a reason that draft was informational. The RFC is informational. It's actually, as it turns out, it's fairly complicated to get this right. That's what we discovered in looking into this, and it was just a lot of. There's like I think the RFC has like over 10 corner cases about things that you need to be careful about, and yeah, it turns out that it's if you try to do acknowledgement condition control, you're very close to shooting yourself in the foot, and you're likely to do it. So I'm generally inclined to just allow acknowledgements to flow as they do and rely on signals on data packets to be the more useful ones. So
there are two things here, right? One is whether you should, if pure AX is a useful, efficient mean to convey congestion signal. I think they are. There are packets. If you're getting the signal, that's fine. The other question is how do you react to this congestion? Either only with data packets, reducing the congestion window, in case you have data packets to send in that direction, right? And if you don't, whether you should actually try to do something along the lines of the congestion control regarding AX.
Yeah.
So what I'm standing is, I think it's useful to receive information through AX. I think it's very useful to actually mark AX in order to avoid to get them dropped. I think it's useful to get them as a vehicle to obtain feedback on congestion, right?
The problem is that when you're getting, so here's the way I see it, right? The ECN marking that's happening on a flow that's only sending AX is getting a signal on bytes that it's not counting, really. So it's a weird signal. So I'm sending you acknowledgements, and then I get ECN marks, and then I receive that signal back. What exactly is that signal telling me? That my rate is too high?
Yes.
My rate therefore has to be the number of AX I'm sending times 40.
No,
in terms of bytes at least.
But that's assuming the case that you're only sending pure AX.
Correct.
That doesn't have to be that case, right? You could be sending some pure AX and some data, right? I'm not saying it's common. I'm just saying it
right. Yeah. Okay. I have to think about that.
And the other argument is, that you want to avoid AX getting more drops, pure AX getting more dropped, right? Because if you don't mark them, right, if you have a high load of, you have congestion, then AX gets systematically dropped, right? And then you're in very bad shape.
you're in worse shape than if you
Right.
weren't compensating for it. Yeah,
Right.
fair enough.
So Miracle, and that's what I basically wanted to say. I think there are corner cases where you have like a very, very low rate, a very congested link where it actually helps. Maybe not in a general case. So this might actually be, there might be room for experimentation here. What's the right thing to do? So maybe you just can give a recommendation that might be useful to change something, and that RFC 5690 is an example, but there's further thinking needed here.
Okay.
Hi, Bob Briscoe. I just wanted to emphasize that the case that Marcelo just explained to Jana, where there's a mix of Purax and data, that's why we've said must reduce Seawind, because then if you are sending data, that will affect that data, and if you're not sending data, it won't.
But if you're not sending any data, what are you doing?
Unless you do the May, you don't have to do the May. But the point is, the congestion's probably because some other flow is sending data. You know, maybe someone's uploading something.
But you're reducing the congestion window based on not the rate that you're sending. You're sending some. You're receiving mark on something. You're reducing something else. There's nothing that has to do with the rate that you're sending.
That's how. I mean, certainly, congestion control should work. That over a round trip time, the probability that you get a mark should be on all your packets,
Yes.
not just on those that have data.
Yeah, but those,
Otherwise, you're ignoring some of the drops or marks.
no. The problem here is that the marks you're getting is actually related to the other side's congestion window, not yours, because you're simply sending acknowledgements back in response to all the packets you're receiving, and those are getting marked.
Yeah.
You look at those marks and reduce your own congestion window. That seems silly, because those acts are not constrained by your congestion window.
No, it's not silly, because if you're sending, excuse me, a small amount of data, your congestion window's not going to reduce, and you're still going to be able to send all the data you want. It's only if you send a large amount of data, the congestion window is going to restrict you. So you're okay.
So yes, your congestion window is restricted only when you send a large amount of data, but you're reducing the congestion window.
Yes.
You're not using the congestion window, but you're still reducing it.
Yes.
So you're reducing something that you're not using.
Yes.
Yes.
And to me, that just seems
It's the
like
same as
an
No,
idle
you're
connections.
yeah. Well, but you were using.
So in an idle connection, you reduce back your congestion window. If you're effectively got an idle connection, or at least an idle half connection, but you're seeing some congestion, then you reduce back faster. So that if you do start sending data, you're correct. You know, you're using all the information you're getting.
Actually,
Yeah.
Actually, funny enough, I think that you could actually use this information to keep a reasonable track of instead of completely starting from slow start again. You see what I'm trying to say? Since you get some information, you can actually try to make this to be an accurate estimate for a bit longer than what
You would
used
have to track more state, not just state, but you would have to track at the receiver roughly what the other side's congestion window is. Not the other side's congestion window. You have to track how many acts you have outstanding in a round trip. That's currently something that you don't track. But yes.
Yeah, I don't think we want to get into.
Sure. It still seems odd to me that you could have a congestion window of 10,000 and 10,000 packets, and I have a congestion window of 10 because I've not used anything yet.
Let me give you.
And I'm reducing it to 5 because I got congestion experience marks on my acts to you.
Let me give you, I think, a different argument. So I think there is value on ECT marking Purax, right?
Yes,
we agree
I agree with that.
We agree with that.
Yes.
Okay. We cannot not react
Why not?
because media doesn't like it.
No, I mean,
So I mean,
no,
conceptually, the fact that you get congestion marks and you don't react to them, that's something that, as I understand, is a message that we don't want to give.
To whom?
Right. In general.
No? I mean, if I'm so the thing is that I'm getting CE marks on my ACK rate. So if I'm not reducing my ACK rate, but I'm reducing my congestion window, it seems odd.
Well. Sorry. Couple of things. First, you are strongly assuming that you're not sending data, which doesn't have to be true.
No, I agree.
And you don't know what scenario you are. Okay?
Fair enough.
So I agree that the scenario that you're suggesting is fairly common.
Yeah.
Right. I'm not
with you.
arguing with that. Right. But you just don't know that. Right.
Yeah. But so, you can know it. But let's go on. Your
that would be a weird optimization, right? If you're only sending pure ACK for the last 10 round trip times or something, then you don't react to congestion. But at that point, I would like to understand a bit more what you usually do with the congestion window, because as far as I understand, if you don't send data at some point, you just reduce the congestion window.
The most common deployments won't reduce anything.
Won't? Even if you have an idle connection, they don't start with slow start again?
Anybody here who does reduce congestion window on idle? Raise your hands, please, now. You on your laptop? In your specs? Yes, so the specs will reduce the congestion window.
The specs
implementations may not.
Okay.
So it's commonly not reduced.
Okay.
Which is one of the reasons I was pushing for pacing as one of the things that you want to have in after idle. But it's not reduced. No, the congestion window doesn't get reset after any time. You don't want to reduce it. I mean, it seems it.
Well, you don't know. You don't have information.
This is a different conversation.
Yes.
I think this is a different. Let's not have that here. But again, the simple thing here is that I'm trying to tease this apart in my head, and perhaps it's just my confusion. But it seems like a sender is sending packets at a certain rate, and that packet rate, its ACKs, is basically directly proportional to the rate at which I'm receiving packets.
Yes.
And I'm getting marks on these, and I'm going to go reduce a variable that is not going to reduce my ACK rate.
I understand your argument.
It's
not that I'm disagreeing with you. I'm just.
No, but so you can do other things with it, ACK congestion control being one of them. But reducing the congestion window seems like an odd thing to do.
Okay, so
doesn't it?
Basically, to summarize, I understand that. One option would be to detect whether you're only sending pure ACKs, and at that point, avoid reducing the congestion window. That would be your suggestion, if I understand.
Yeah. Yes, as a first. Certainly as a first.
That would be your suggestion.
At least in that case, I don't think that we should be reducing the congestion window. It seems.
And you still don't want to do your.
Well, even
5690. I'm trying to summarize.
No. May seems like the right thing to say there. I'm saying that it's kind of hard to get this right. Okay. So most people are unlikely to actually do something there. Just realistically speaking.
Right.
In terms of data rate, again, the same thing comes to mind. If I send one packet and then 1,000 acknowledgements, because that's the rate at which that's the number of packets I'm receiving. This is common, by the way, right? I send one request, I receive a whole object back. So you're sending me 1,000 packets, and then I send one packet out. So if that happens, then I'm going to reduce my congestion window again from 10 to 1.
No, but again, that's why my wording was, if you haven't sent data for a given period that needs to be determined, right? Yeah. So maybe we can include that particular situation. I'm just saying that's a proposal. I mean, then we tune how much, for how long you haven't sent data, and that's a. But first, let's agree on the approach, and then we figure out how to tune the parameters.
Yeah, and I'll say that it seems to me that if we are looking at signals on ACK packets, those should actually apply to the sender of data, because ACKs are simply a blind response to the data that's being received.
Yeah, because
those aren't controlled. Those aren't directly controlled right now, and that's what I'll say.
Okay.
We still have 8 slides to go and 2 presentations, so I'm closing the line after Gori.
Mia Kulevin, first of all, on Jana, on changing the congestion window. So the problem is congestion information will be outdated after a while. like in both directions. If you increase your congestion window or if you reduce your congestion window. And so if you don't send any data, you have like outdated data information about congestion, you don't want to react to it. But I think that's true also for having like a large congestion window. After a certain idle time, it just doesn't make any sense anymore because it doesn't reflect the current situation on the link. So maybe this can be used to reset to the initial window quicker than we do it right now. Reducing it below the initial window probably doesn't make too much sense. And then my second point was because you said we should not react to it. So first of all, there are two things. One is you should not send a marking if you cannot ever get feedback, because then you cannot react to it. If you never have feedback, then you can for sure not react to it. And then if you get the feedback, you should react somehow to it, but it also doesn't have to be immediately. You can also say, I'm reacting over time at some point if I have a certain number of markings or whatever. So what the reaction is can be very different.
Okay. Okay, just to summarize your case, I understand. Okay, no, that's fine. I think I got it. That. All right.
Just in response to Jan, I just want to sorry about this. Put a scenario. Say you're using HTTP2, and you're doing byte range gets, and so you're getting a large number of packets each time you do one, and then you're sending a little, another byte range get, and you're controlling what the server's doing over multiple streams, all in one connection. And then, by your logic, if one of those byte range gets marked, you would sort of reduce your CWIN less than if a large packet got marked. I'm trying to do the case between a little ACK packet, a small get, and a large data packet. You see what I mean? And I'm trying to say that just because the ACKs are marked, it's actually telling you what your congestion window reduces to.
It doesn't, because the ACKs aren't being sent based on your condition.
Correct. So it's only reducing. It's never increasing.
So if your ACKs were like, you're sending 100 times more ACKs than the data packets you'll ever send.
Yep.
Your congestion windows, with small congestion windows, you might be able to send that without getting any ECN marks at all. Therefore, you might never reduce. But you're reducing it based on the hundreds of ACKs that you're sending. And you're reducing this with 10. But you're still not just sending 110, you're going to send 105 packets.
Yep.
This is Michael speaking. As a first, for the remote participants, it's very hard to follow conversation. And second, I've actually closed the mic. So could we please make this quick?
Quick?
No.
Fast.
Gary Fairhurst, I think introducing quick at the moment is not going to simplify things. Okay, so just 2 points, and they are quick. The first one is, if the ACK rate isn't reducing and we're CE marking them, then we're always going to get this reduction. So CWIN is just going to drop into the floor, isn't it?
Yes.
Yeah. Okay, the second thing is we did all this work when we did the CWV stuff in, what was it, 7661? And we got some conclusion there. It seems like we're reinventing the same thing here. So let's just think what happens when you're not sending data. The CWV work we did in TCPM 7661,
okay,
which is what applies when you don't send data, and whether that's a good choice or a bad choice, whether you need pacing, etc. So I was just saying, let's take that one into consideration when we think about what to do.
Right, that's what media was kind of hinting. Okay, that's good. Thanks. We'll do that.
So please continue, but
Sorry?
keep it as short as possible.
Yes. I will try. Okay. So we are also proposing to ECT marks on retransmissions. So in this case, what we did is we strengthened the language regarding on the checks that you need to do when you receive a CE mark, a retransmission with a CE mark. Next. We also propose to mark fins and resets. There is a kind of trade-off here. On one hand, if you mark them, you protect. I mean, you cannot react to this, right? I mean, there is no reaction if you get a mark on a fin on a reset, right? There is no more data to send, so that's it. So why do we do this? Well, in order to prevent them from getting more drops when there is a high level. There is a high number of marks, right? So the counter argument for not doing this is is that if you mark them, if you enable for them to be marked, then they will not, there is less likely they get dropped if you are under heavy load. And when you are in a DDoS attack or something like that, the attacker can actually use this in order to send these handful packets with less chances to getting dropped. Right. However, so the first observation is attackers will send them marked whatever in no matter what, right? No matter what our RFC says or what our specification says. So we cannot do much about them. And on the other hand, if we allow them to be ECT marked, then it is more likely that in normal situations they will actually get there. So that's why we decided to go for it. Next. So we did a lot of progress since last revision. Again, thanks all the reviewers. It was very, very helpful. And this is a summary of all the changes. I'm not going to go through them. I don't know if Andrew has.
Andrew McGregor, just a very quick question. Does this mean that the network devices can completely remove all the special cases for different kinds of TCP control packets in their ECN marking decision?
Sorry, what do you mean by remove?
So at present, no, I see where my misconception is. Sorry.
Okay. So we did a few experiments to get some data about this. This is basically an experiment where trying to figure out if using ECT marked packets for launching an attack is more efficient than sending regular packets, right? Given that switches are supposed to turn off ECN treatment when there is a high load, right? So next slide. So basically, I'm not going to go through this, but basically what you see here is different situations where there is an attack, there is a TCP flow, either ECN or non-ECN capable, that it's being used, and suddenly attack starts, right? So the ECN flow, the legitimate flow is the one that it's in black or in red, right? At the bottom here, right? And this is the attack that starts. It's very hard to point from the square. And so basically what you see is you are launching the attack with ECT and without ECT. And basically what we're seeing is that the reaction is the same. There is a slight difference because at some point the ECN mechanism in the ECN mechanism in the router is still working, but suddenly it gets deactivated. Actually, it gets deactivated in these red lines here, and then after this is exactly the same. So we don't see too much difference if you are using ECT marked packets when you're launching an attack and we're using just regular packets, right? So basically that's the conclusion. Next slide. And then we're doing a bunch of experiments on figuring out if these actually ECT marked control packets and retransmissions, all these type of packets actually how they get processed by the network and by the servers, right, that are out there. Our conclusions is basically this, that they basically have the same treatment than ECT marked packets, right, than normal packets, right? When you send not regular ECN on data packets, whenever an ECT data packet goes through, control packet gets through as well, and so there is not too much difference. There is no special treatment of control packets as what we can see now. So we're going to report this, the data set and the results of our experiments in probably for the next meeting. And okay, and we have an open issue. I was thinking that was the last one. So this is one open issue that both Padma and Gori brought up. That is, what happens if, because you send the ECT marks on the scene, let's suppose, and you manage to see that ECN++ is being supported along the path. What happens is, in the middle of the connection, you start losing ECT marked packets or ECT control marked packets, right? I understood that because there was some change in the routing and now suddenly you get a different middle box. So is there any way you can actually react to that? We haven't actually come up with a very neat solution for this at this point. This is still an open issue. I'm not seeing that it's very pervasive, the fact that control packets are treated differently than data packets. So this is not, we don't see that this is, there is boxes that do this specifically for control packets. This may happen to you. Sorry? Haven't found any. Right, sorry. Yes, we haven't found any cases that's the situation, right? So probably, maybe that's not a big deal. I don't know. Miriam.
So this is an open question for ECN in general. So you negotiate ECN, you mark your packets, and then you detect that something goes wrong, and then you should stop marking your packets.
Yes.
So, and like, yeah, we don't really have a good solution for it for ECN in general. And if we would have a solution, it would be the same solution here. So I don't think it needs to be addressed in this document.
Okay, that would be great.
Please go to the mic if you comment something.
So Bob said you can't detect it. You can detect it with accurate ECN when you have the accurate ECN option.
Go to the mic.
He said you cannot detect if you're using pure X. And Bob said that.
Okay, so we take this to mailing list. I'm out of here. Thank you very much. Okay. Well, next steps. So we're going to post a 0.1 version that actually incorporates, actually has been submitted already, that incorporates all the feedback and all our changes reacting to those comments. So hopefully we were able to address most of them. I would really appreciate if people who actually review the document can check that it reflects what you wanted out of the document. We need more measurements. So we have done a few. We hope to report probably in the next meeting what we found, and more measurements are also welcome, and more reviews as well. But I think the document is in pretty good shape thanks to all these reviews that we had. So I think we are pretty good. I'm done. Thanks. Sorry for being so long.
Yeah, no, that's okay. So this is Michael speaking, and this time more or less as chair. So I'm wondering a little bit about the cross dependency between ECN++ and accurate ECN. And I'm not really asking that to you. It's more to the working group. So because I understand there are some cases where the two could be deployed together, or it even gets value if you use them in combination. But my question to the working group is this something that the working group really believes is an important case? Also, just to explain why I'm asking this could mean, for example, that we could publish the document together, something like that. So I'm particularly interested in cases where implementers would only implement one of the two.
So just to help with this question, this is the summary, right? I mean, basically what the dependency is as of today, if we don't change the pure X and stuff, right? What the draft reflects today is this, right? The dependency is on the scene, right? All the rest, it's okay. Just to summarize, okay?
Yeah, and one more thing to add: there's a dependency in this direction, but not in the other. So
Yes.
accurate ECN doesn't depend on this document.
Yes.
There's a dependency of this ECN++ document on accurate ECN, but there's no dependency of accurate ECN on ECN++.
Correct.
Yeah, I understood that, but I'm more interested in if, for example, implementers would be interested in implementing that and have no plans ever implementing accurate ECN. So that would be something that we would have to understand from a process perspective, for example.
Yes.
Yeah. So Bob Briscoe, and maybe I can put this in terms of companies, because the RFC 3168 column there is more for people that have already deployed ECN 3168, like Apple, right? And what this is saying is you can get the advantages without also implementing accurate ECN if you want, right? But you don't get the advantage on the SIN, which is one of the big advantages. So it's sort of to allow companies like Apple to think, do we want to do that? So
Yeah,
I'd like to know
I
the
understand
answer.
it perfectly.
Yeah.
I'm more, as I said, I'm asking the implementers in the room.
Yeah. I'm just making the question clear to them.
Mia Kulevin again. I'm not somebody who's going to deploy that, but I think one of the biggest advantages is having it for the SYN. So
I mean, yes, but for the SYN we could also find workarounds, I think. I mean,
what?
It depends, but as I said, my question is more on the implementers. If there's a strong case for implementing only a ECN++ and not accurate ECN, and if that's not I mean, it's important for us to understand how closely those two things would be coupled, because it impacts the process that we have to follow.
Right, and not only the process, but if that's the case, I would assume there would be a strong pushback to make the dependency of the SYN. Right, so we probably need to look if there are other ways of doing this.
Yeah, for example, and that's why we would really like to understand that case.
Joan Rouge, Fastly. So one of the problems with the SYN case with ECT is it's not always obvious what the fallback case is, because there are boxes which hash on the ECT field effectively because they take the whole type of service. And so currently you would establish a SYN and ECT is 0, so it's fine. If you negotiate ECN, you end up hashing in an Anycast network to potentially a different box and you get a reset. If you do it straight away with ECT and you just get a reset later on, it's completely not obvious that that might have been because the congestion marking changed, and so you ended up in a different box. And I didn't see really any, in the measurements in particular, the assumption is ECT makes it through, so success. I'd be curious what happens if you then change the marking to see if you end up in the same place. Because for lots of CDN networks, that might not happen.
I have that data. I look into it.
Okay, cool. Thank you.
Andrew McGregor. Of course, if you're hashing on the entire byte in the presence of ECN, your network is broken. So, and also most of the boxes that do that with the configuration that was suggested in their documentation for hashing there have a different configuration that does it the right way. So I'd say that many CDNs and the like who might investigate deploying ECN that don't do it at the moment would do it because of the benefit on the SYN here, and therefore would want to do accurate ECN. I think the case of not wanting to do accurate ECN kind of means you don't want to bother with this either, right?
That's what Bob thinks.
Yeah, that's it. Doing this without, basically, this simplifies the implementation anyway by removing a bunch of special cases. So yeah, you might do it just for the simplicity benefit, even though it actually has little practical impact.
There should be a strong case, as what Michael was saying, because you will eat quite a few code points in addition if you wanted to support all the possible combinations.
Totally.
Right. So it will be expensive if you want to do some other things than this. Right. So there should be a strong case, but that's what he's asking.
Yeah, I think the benefit on the SYN is most of the win, and accurate ECN has its own benefits. So, yeah, I think from my point of view, the main benefit of doing either of these things is doing them in combination.
Okay, good.
The line is closed after Bob.
So just to agree that the whole hashing thing is completely broken, but it does give a barrier of entry in terms of implementation cost, because you end up paying the cost in customer support for a broken box somewhere else in the internet. And so this is a hurdle for deployment that you have to consider, right?
Yep.
And this is the whole problem with the original deployment of ECN, which had the same kind of implementation hurdles, which were kind of waved off because of the huge benefits of ECN. So we've been through here before, I think.
Now Mia at Bob's, how's it called? Time slot.
So I think the point you mentioned with the hashing is true for all ECN uses, not only for this case. You have whenever you want to use ECN on any packets, you have the problem.
Yeah. Okay, I'm out. Thanks.
So while we are changing and going to the next presentation, has everyone signed the blue sheet? So you haven't? So who's presenting this? Ah, okay. So go ahead.
Okay. Hello, everyone. Today I'm here to present the new TCP option, TCP low latency option. And the motivation behind this option is that the NICs in the data center machines recently are usually up to speed 10 gigabits per second. That makes the RTT time less than 100 microseconds. And this pretty low RTT time makes some of the fixed parameters in RFCs outdated. And one of them is RFC 1122. It defines a delayed ACK mechanism. And in most modern operating systems, it usually delays ACK for 40 milliseconds up to 200 milliseconds. And as you can see, the delay is mostly about 400 times the RTT time. And also for minimum RTO time, the retransmit timeout, RFC 6298 defines a minimum RTO time of 1 second, and that is 10,000 times of the RTT time. And also above the two above parameters, both of them introduce unnecessary delays to the data center machines, and also yes. So next is the RFC 73-23. It defines the TCP timestamp option, and the granularity of the timestamps is usually 1 millisecond to 1 second. And even though with granularity of 1 millisecond, it's still 10 times than the RTT. So it makes the RTT measurement from the TCP timestamp option not that accurate. So we propose this one solution to the above problem is that during the connection establishment phase, the local side will advertise some hints of the above parameters so that the remote side will pick the hint up and then do some adjustment on the related parameters. So if you go to the next slide, here is an example that explains a little bit more how we do this. So during the three-way handshake, when the active side sends a SYN, it will include this TCP low latency option and take the maximum ACK delay as an example. If the TCP low latency option will specify that the maximum ACK delay used on my side will be 10 milliseconds, so that when the remote side pick it up, it can use this parameter to do some adjustment on its retransmit timeout. And similarly, from the passive side, when the send SYN ACK, it will also include this TCP low latency option and specifies that my maximum ACK delay will be 5 milliseconds, so that the active side can also do some adjustment accordingly. And after the connection is established, when the send side wants to send the packet and the receive side receives it, and if the delay ACK is active, then the receive side can only delay ACK as up to 5 milliseconds as it advertises before. And also for the send side, when you do retransmit, the maximum retransmit timeout on your side will be set accordingly. That will be it will be greater or equal to 5 milliseconds. So the format of this option, similar as all other options, it will have kind, and this will be an IANA assigned option number, and the length will be 4 bytes. And in the initial draft, we only include the maximum ACK delay, so 2 bits will represent the maximum ACK delay unit, and 10 bits will specify the maximum ACK delay value. And there are 4 bits reserved that will be for future use. So as there is no IANA option number yet, so we are going to first use it with experimental ID. So then the kind will be 254, and the length will be 6, and the experimental ID that we get is F990. And the rest are the same. So when the user wants to use the specific maximum ACK delay, the implementation should no, it's a must provide a user API to configure it, either for a specific connection or for all TCP connections.
Wait until the end. Just carry on.
Oh, okay. So we are proposing that in Linux, we will use two APIs. One is through the IP route command. So you will be able to use it to specify a maximum ACK delay per route, so that all the connections going through this route will use that. And the other is through a socket option, where you can specify this for a specific socket. And the implementation should use a value as close as possible to the user-specified maximum ACK delay. The reason we use as close as possible is mostly because of the timer granularity limitations on the operating system. If the user specifies a timer that's too low, will be rounded up to whatever the operating system supports. And when the user specifies a maximum ACK delay, this will be announced in the TCP low latency option. And this option will be only included in SYN and SYN-ACK packet. And normally we're hoping both sides support this option, so that it will advertise their own MAD option to MAD value to the other side. And we are also proposing that if the active side does not announce this TCP low latency option, the passive side will not announce its own value, just to be conservative. And when the receiver receives the maximum ACK delay value, it can use it to adjust its retransmit timeout calculation. And according to RFC 6298, it currently now does a maximum of smooth RTT plus k times RTT variation, and then and do a maximum of this value with 1 second. So if you receive this maximum ACK delay from the other side, then you no longer are bound to this 1 second upper bound. It will now you can do smooth RTT plus k times RTT variation, and then just plus a maximum ACK delay received on the other side. And also, when we are trying to compute the probe timeout in the rack draft, initially it was using there is this WC del ACT. Initially it was set to 200 milliseconds. Now, if you receive this maximum ACK delay value, you can replace that with what you are receiving. And the status of this is we have already submitted the initial draft, and the second draft is currently so the first draft only includes the maximum ACK delay, and the second draft will also be including the microsecond timestamp. And the maximum ACK value, maximum ACK delay has been used in Google since 2005. And the microsecond timestamp option has been used in Google since 2015. And we are also currently working on the upstream Linux implementation for both of them. And we are also hoping that other platforms or operating systems can support it. And that's it. Thank you.
Bob Briscoe. I've read this draft very carefully. You'll get a long written review of it because, but in the last week I had a lot of other things to do, so I haven't actually written it up. But it's, if I can summarize my comments, I support where you're trying to get to, but not the way you're starting. And maybe I need to start this with a question. Why are you bringing it here? Presumably because you believe this has benefit for the whole internet, not just inside Google, yeah? Right. And then all these arbitrary values are all wrong except for certain cases. You know, they're right for one case and then they're wrong for all the other cases, right? You know, when you've got a host that's using different round trip times for different flows, picking one is always wrong, apart from in a very few cases.
You mean picking one for all the connections?
Yeah, picking an arbitrary number and configuring it and saying this is the number we're going to use. So I think the way around this, the way to think about this is, once a flow has started and you know it's round trip time, let's try and make all these numbers go away and base them on the round trip time, and only have arbitrary numbers before you start, like for the SYN, you know, for the timeout on the SYN, and everything else. Why does it need to depend on something that someone's configured rather than what you've just measured, right? And so
I think the main reason that we want to pre-configure it is because, say, if you're in a data center environment and you have prior knowledge about what the maximum like round trip type will be inside the data center, so that you can. But
I'm not saying you don't do that, but you only do that before your flow starts.
Right.
For the initial RTO. Right?
Okay.
Once your flow started, it's better to have you've got your round trip time measurement from the handshake, and then you base all your numbers on that. And the reason why I say the way you've started is wrong, by just doing one of them first, which is the initial RTO, and not doing the delayed ACK, it means you can't reduce the initial RTO because you haven't reduced the delayed ACK. Whereas if you know, because otherwise you'll get spurious retransmission. So you need to do them all together, and then you'll only need one bit to say, I'm doing this, are you?
No, I think the thinking behind this is during the connection establishment phase, you communicate this with each other, so that before the connection builds, you adjust its corresponding parameters, so that after the connection establishment is finished, then you can use this.
Yes, but the point I'm making is that by that time, you both know your own round trip time, and you've both got an estimate that's reasonably the same as each other. So if you just then say, right, we're going to use our own round trip time estimate, we don't even have to tell each other what it is, because we should have both measured a similar round trip time. Yeah?
To Google. Bob, by your argument, why do we even have this max RTO or whatever limitation from the RFCs, right?
For the initial.
No, we also have that for the data connections, right?
Yeah, the issue is that the thing that we're advertising is something that the sender can't necessarily know what the receiver's policy is. So that because typically what happens is the sender sends a bunch of data and you're not seeing any delayed ACKs because you're sending enough data packets that the other person is ACKing immediately.
Yep.
And the thing is, you don't know what the other person's delayed ACK policy is until you've had a spurious retransmit. So that you can't really measure the other person's delayed ACK policy.
This one bit says, we agree, we're both using this policy.
Okay, so you're basically suggesting compressing the option to agreeing on a new good value and
no, not agreeing a value, but agreeing a proportion of your round trip time is for all these values.
Okay, I see. So you're suggesting that we would have a standard fraction of the round trip time that would be used instead of the value. Okay.
A host on the internet is potentially talking to a media server in your home, with a 500 microsecond round trip time, and it's talking to another host that's got 200 millisecond round trip time over the other side of the world. So you can't configure it to any good value.
Right. Although in our experience, the things that are really constraining the delayed ACK time are sort of end host considerations that have to do with the granularity of the operating system, and not really much about the network path. So,
okay,
but
the formula. If you can go back to slides, that one, having the configured value once you've got started as a minimum can be awful. It's really unnecessary once you know your round trip time to then still have to wait I don't know what you saying this. Was it 200? No, 200 milliseconds was it or something?
No, we're suggesting that the receiver would decide what its timer granularity is or what its timer value is for its delayed act, and it would advertise that as a hint.
No, that's the granularity one, but then you've still got the max act delay in there as well.
Right. So, and we would suggest a value of 5 milliseconds. But you think that's too high, and you'd like to use a fraction of the round trip time. Okay. Yeah, we can definitely incorporate that maybe into future future drafts.
You know,
Sure.
Hi, Brian Trammell. While we're talking about how to clamp this thing so that it's not dangerous, this seems incredibly dangerous to me in an unauthenticated header, because just random stuff on the internet can say, oh, I would like to flood things down or on the return path on the backside for me, so I'm actually going to clamp your max RTO down to essentially 0. So there needs to be some way that you're not going to essentially get a bunch of spurious acts as soon as you drive the state machine into the point where it's going to start timing out.
Huh? Well, as close to 0 as you can be. Like, I mean, the minimum value, right? I mean,
there are ways. It seems like it would be very easy to implement this in a naive way that would be easy to have an on-path device forge this header and drive your state machine to a place where you're going to be sending packets where you wouldn't otherwise be.
Are we talking about securing TCP at this point?
What I'm talking about is the parameters that this extension allows you to reach down into TCP and change seem like things that we should it seems a little bit more dangerous to me than sort of the way that Bob's saying things is just run everything off the RTT, right? Because that's running everything off the RTT is much harder to fake down to below the actual RTT.
Well, this is not. I mean, yeah, Neil Cardwell, Google, one of the co-authors of the draft. I mean, keep in mind that the thing that we would be driving down here is essentially a term that has to do with the variance of the acts. We've still got the round trip time and the regular, k times the RTT variance in here. So the thing that we're changing really is this sort of artificial 1 second value, and we're changing the.
You're still sending. You still have to have. Okay. Yeah.
Yeah. So it's.
Okay. Yep.
Okay.
Yep.
Okay.
Great. There still has to be demand to send. Okay. Okay. That scares me slightly less. The other comment I came up here to make is actually obviated by something Bob said. So thanks.
Andrew McGregor. I was going to comment about number representations, but actually that's been obviated by discussion. It seems to me that you need a little bit more than Bob's 1 bit. You also need to know what each end's timer granularity is. But I think that's all you need to communicate is we're doing this, and by the way, the timer granularity is X. Yeah. I think you could find a different number representation that might have a wider dynamic range to future-proof it and use fewer bits at the same time. But other than that, yeah. Yes, I know.
So this is Michael speaking from the floor. So reading this, I'm wondering, does this have to be in the SYN? Because, I mean, SYN space is scarce. So could there be a design where you basically achieve what you want here, but you negotiate it after the SYN?
Okay.
So that would be something I think you should think about, because I don't know the answer, but SYN space is scarce. So if you could do it afterwards, there could be value in at least thinking about a mode where you negotiate it after the SYN.
Because I think the reason we put it in the thing is because then immediately after the 3-way handshake, you can use this value to reduce the...
Sure, there's a trade-off here, but I mean, the SYN space is a scarce resource. So if you lose maybe the first handshake and you can't use it for that first handshake, but you can use it afterwards, maybe that's still good enough. Or as I said, at least I would suggest of thinking about if there's no optional mode of doing after. Maybe the answer is no, but I think it's SYN space is scarce. And we keep adding things to the SYN, and sooner or later we will run out of space. So we have to start thinking about it. But I don't argue that it is possible. I'm just saying it's valuable thinking about this.
Okay.
Yeah, Kulevan, I had the same comment, and I want to additionally say this is not a negotiation. This is not something where two people have to agree to do something.
Right,
it's just I let you know that I do something, so we really don't have to do it in the handshake.
Okay.
Jana Iyengar, going back to Bob's idea, I'm not sure that actually. So the idea of indicating via a bit that both endpoints would use a fraction of the RTT plus indicating the timer granularity seems like it's too much information that ultimately both sides have to coalesce into exactly this. What else am I going to do with the timer granularity of the other side if I'm not going to use it to construct this particular value ultimately? It seems pretty clear. It doesn't. It seems to me that information might be richer than you really care for it to be. I like the idea of using RTT, but I'm not sure exactly what to make of setting a timer granularity instead of this number, because they're both absolute numbers at that point.
Maybe I was thinking that you both agree to use the coarsest granularity of the two of you. You know,
which is fine, but it goes to the same thing. You're sending a constant at that point. Now the constant could be this, or the constant could be that.
Yeah, okay. The reason why I didn't think of that in this is that, I mean, Richard Scheffenegger already did this thing where he was trying to use the timestamp. You know, what's the resolution of your timestamp option, and we've already had possibilities on the way to do that. And I was sort of in my mind assuming that had already been done, and then, you know, you only need this bit, but yeah, it's not that.
Right. So it sounds like if I was to, so it sounds like in the current state of the world, you would send a bit plus a constant, and in this case we send only the constant.
Yeah, but Bob, your constant is not you're not only sending the time granularity. You're sending this maximum act delay, which I think is wrong because it only doesn't apply to the whole range of round trip times you got on the internet. It's going to be very badly wrong for most of them.
Right. But as an endpoint, I have to figure out what to do. So if for instance, if every endpoint was to say fraction of RTT plus timer granularity is my max act delay, and ship that. If that's what they effectively ended up doing, you would be. I'm saying that the endpoints have the same information in your world that they do here. They're constructing that information from the two bits that you're handing them. One is the 1 bit and the second is the constant.
I didn't explain my motivation. My motivation was I really objected to this line. If you're going to use this, you must configure it. And I thought, what, you mean every user's got to configure their machine?
No, it's not. It's not a you must configure it. It's you can configure it or not. No. What I meant is the implementation must provide an API for the user to configure it, but the user is not necessarily to configure
yeah,
it.
I appreciate that, but what I then thought is, okay, so how do you configure it? What do you configure it? What advice do you give on how do you configure it? And the only advice you can give is base it on the round trip time. So why not just use the round trip time?
Yeah, so I think in most operating system it has a default value there. For example, in Linux,
but that's
it's
wrong.
200 milliseconds.
So let's change it. You know, it's wrong to have this constant that doesn't apply in all cases.
Maybe I give you a little history. You know, we've been using this for the past. Sorry, Jerry Chu, Google. We've been using inside our data center. We actually we first do IP address check. So even our data center server, sometimes they talk to long RTT, right? So yeah, you can argue that if we have this configuration, it's less versatile. You know, it's not as useful as we can get rid of it. But just by this, right? And inside your data center, you know your max parameter RTT is 5 milliseconds. You configure it, right? But if you get rid of this, then you will tie it to RTT. But like Neil said, this value have to do with also the max delay have to do with your server side operating OS delay. You would like it to come back to piggyback on data. So it's not all about RTT on the right.
But that's the only variable that the granularity and the RTT. You don't need this. Is this max act delay that is the problem? You should not be.
Well, not just granularity of RTT, but not just the granularity of timer, but also your policy on the OS side. What is the max act delay, right? That is sort of separate parameter from
Yeah. I think in my mind, the max act delay sounds a lot like how you're thinking of the timer granularity.
Yeah.
Because yeah, I mean, there's some minimum timer granularity that makes sense for a delayed ACK, and I think in practice, people should probably try to delay their ACKs for that minimum feasible amount, and then communicate that as a hint.
Hang on, sorry. I'm using the wrong variable name. I didn't mean the max act delay, so that could be the confusion. This is all different variable names from what's in the draft. So
the G is the standard granularity from 5681, or
Yeah.
sorry, 6298.
But where's the min RTO in this?
Main RTO is the 1 second.
It's in the SRTT. You're talking about the min RTO. That's one second right there is replaced by max act delay.
Oh yes, it's the 1 second. That's the bit. Yeah.
Yeah.
That
You want to get rid of the 1 second.
well, not the thing that replaces it. You also can get rid of, but I can't see
Max act delay. That's
max act. No, it's. Oh, I don't know.
So Bob, I think what you're saying is there's a constant which is 1 second. We should absolutely get rid of it. And I think so. Yeah, exactly. I was going to say yes. We should totally do that. So so I think what might be a little bit of confusion is that what you're saying is use G, which is the granularity. Don't have a max act delay independent of G.
Multiple things into a new sort of G that means something else.
Right. So or a max act delay that includes G and something else. And that's the part that I think I disagree on. I mean, it seems to me that if what you want to indicate is how long do you want the other side to wait, if it's based on granularity and based on something else, then you just ship the number that you want the other side to wait for, instead of just shipping a granularity, and have the other side construct something from the granularity. But yeah.
So I think you don't want a constant value. You want something that depends on the round trip time, and it might be a fraction. And the granularity, yes. But you don't want a constant value there. You need the granularity is something you configure in your, or like it's depending on what your operation system is doing, yes. But it's also not a constant. It's not a user-given constant.
And another thing I'd like to inject here is that if it's something based on the RTT, then we get into this question of the fact that the two sides don't know what the other person's RTT estimate is. And so if I'm trying to communicate that I'm going to delay X by a quarter of my RTT estimate, then you're going to wonder, well, what's your RTT estimate? I have no idea what that is. So this is one of the reasons why we were advocating for just communicating this as a constant value at some point in the connection lifetime. And we take your point that that might make sense to allow this to be negotiated later on in the connection, just to save SYN header space.
My thinking on that, Bob, this is Bob. My thinking on that was that you're also allowing each end to estimate, not use what the other end says, but use what it thinks is best. And so that's got a similar error on it to your estimate of what the other end's round trip time is.
The line is closed after Jonathan.
David Black got up to try to say something a little higher level than this detailed attempt to redesign it based on PowerPoint, which is this mechanism has clearly been designed and is in productive use in data centers where you know a priori the exact characteristics of the network.
Yes.
And as a result, advanced configuration makes sense because somebody actually does know what's going on. When you broaden it out to the broader internet, that a priori knowledge is no longer necessarily there. And so there needs to be some way to check that, oops, we goofed. No, it's not working the way we expect it to, and therefore we're going to do what's appropriate for our higher delay path. The round trip times sound like a good way to go there, which is if you did something like this and then check the round trip times, and all of a sudden, oh good Lord, the round trip time is 75 milliseconds, maybe we didn't want to do this. That would help greatly to at least back out of this when you discover somebody's put it in the wrong place.
Jonathan Looney. I just wanted to say I think the mechanism may not be perfect as specified in the draft, but I think this is definitely something that we should be doing. And, I think that's exactly the kind of thing that we can hash out over multiple drafts in the future. But I fully support the work. I know there's other people doing work in this area, and I think that TCPM should be taking this on.
Thanks. Mia Kulevin, adding to David's point. So I know that you did this because it's easier for you, but if you have a priori knowledge, then you can configure it everywhere. You also know what the other end is doing, so you don't need to exchange information anymore. So I don't think the data center case is the interesting one here.
Except when you have data centers big enough that you can't instantaneously upgrade all your machines to the next operating system revision, which I think is the kind of situation we run into. Also, there are more situations coming down the pike that are where this would make sense. So, for example, in cloud scenarios where you might have thousands of machines in the same data center, but they're all different vendors, different operating systems, and they need a way to know what the other person is going to do. We're thinking this might be useful. Neil Cardwell, Google.
And since we've closed the line as our 2 sentences. No, we've closed the line.
Jenna Iyengar, Google. I think what Jonathan said, that I think broadly speaking, the problem is interesting. I agree with Bob completely that the 1 second is arbitrary, random is not used in practice. So it's actually quite nice to be able to change that and maybe think about something more realistic and more useful and more practical that can be used than sort of the 1 second. Maybe the precise mechanism here is not something that we may want to do for the broader internet. I think it seems like it's close, and that can be hashed out over time. I think there was 1 sentence actually.
A very long one. Okay, so I think we had enough discussion on that one. I think there is some positive feedback here in the room in general. Of course, the details that probably need to be reviewed. So I think we encourage the authors to look into the feedback that they got and possibly come back to us with a new version.
Next presentation.
Hi everyone, my name is Shafiqul and I'm going to talk about TCP control block interdependence. So a quick recap what we have done so far. So the reason for this BIS revision was to provide an overview of the current implementations. So far we have data from FreeBSD, Linux and Windows, and we want to provide clarification and updated mechanism details. The key issues that we address are to provide better details on shared TCP parameters and shared algorithms, and we want to advise on the limits of sharing, when to share and when not. And also we want to provide interaction with TCP options. We have added a table for it. And also we have added all the listed all the options in the appendix. Next slide, please. So we actually are currently seeking working group adoption as BCP so that we can recommend best practices based on the current implementation experience. And if it gets adopted, we want to fill out the TBDs related to sharing table and focusing on the known safe behavior, what are okay to be shared and what are problematic in the internet today. And we want to leave the cost benefit decision to implementer, but explain the aspects of taking such decision. And we are also open to finding information related to other operating systems. Thank you.
So this is Michael speaking, this time as chair. So the situation for this draft is as follows. We've run an adoption call on the mailing list. We didn't get a lot of feedback. Actually, we got 0 feedback. And that's why we wonder, or we would like to check in the room if there are thoughts on this draft. So at the moment, the feedback that we got is, honestly speaking, not really sufficient to adapt it in the working group. So that's why, first of all, I would like to ask the room, are there any thoughts on this document, any feedback that you want to give to the authors? Or are there any reasons why you've not commented on, for example, on the adoption call, things like that?
Andrew McGregor. I didn't comment on the adoption because I wasn't paying attention on the mailing list. It's a widely deployed behavior. It's sometimes problematic and sometimes safe. And I actually think there is value in documenting when it is reasonable to configure this and not. And of course, there are always going to be parties out there who configure it in a radically different way that they're not talking about. But, you know, at least documenting the basics of why it is and is not safe to share various of this data has value. So I think it is worth adopting, even if it's insufficiently controversial to attract comment.
Okay, then, as a more formally speaking, I'd like to raise two questions to the room to check the sense in the room. The first question that I'd like to ask is if there's a belief in the room that this is worthwhile to document in this working group. And so I actually will ask two questions. I will ask first if you support that, and I also will ask if there are any objections. And so that will be the first part of the question. And then as a second formal question, we have the staters out there. So there are a couple of different things what we could do here. You can see on the slides, the authors proposed this as BCP. It's also possible to do this, for example, as an informational document. So that's why the second question that I will raise to the room is if there's support for this being a BCP. So, but
under the assumption that the first answer is
under the assumption that we get some positive feedback for the first one. So starting with the first question, and maybe we do it with a show of hands for that one. So please raise your hand if you think there's value in documenting that behavior in a TCPM document. So please show your hands. Okay, so for the note takers, this is of the order of 10 people, and that's a pretty strong feedback. And is there anybody in the room who thinks that it's not a good idea to document this behavior? So for the note takers, there is no objection. So there's clearly a sense in the room, there's value in documenting this behavior. Now coming to the second question, so on the staters. So in particular among the people that think there is value in here. As those of you who think that this should be a BCP, please raise your hand. And I see, and maybe I have to add, I mean, the working group can change the status afterwards. Also, the question is actually about the milestone that we would add to the charter, so to be precise.
So, Gary Fairhurst here. I would suggest in a discussion that we should postpone deciding whether it's a BCP, that it could be a BCP from my point of view, if lots of people here say this is the right document and this is the right advice. It could easily be informational if people didn't actually sign up to that later on. Maybe we don't have to decide now is my contribution.
We don't have to, that's absolutely correct, but I mean, we don't have to think about it if there's no support for it ever being BCP. So I fully agree, and this was also one of the options that I gave in my adoption call, that we postpone the question. But I still am in particular interested if there's support for it possibly becoming a BCP.
Jana Iyengar, Google. I'm not very excited about it becoming BCP. I'm more interested in it being informational, because I think there's the rat hole of, hey, this is what these implementations do. Now let's discuss if that's a good thing or not. I'd like to avoid the second one, because I think the value in this draft is the first one, which is this is what implementations do.
So I would like to add something. As per the meeting minutes from IETF 96, where Lars and you mentioned as well. So what Lars suggested to have it as BCP, like putting BCP with an appendix where all the informational stuff should be sent to the appendix, and focusing on what are okay to be shared now and what are problematic today. So then basically it would fit quite well, and that actually we want to propose, and we intend to do.
I've had long trouble with the BCP line, because we don't have a place to document deployed stuff. We tend to push it towards BCP. It's hard to make judgments about things that are deployed if what we want to say is this is what's deployed, not necessarily say this is the best practice. But I think that's finagling that can be done later. I'd like to have a whole new thing called deployed current practice or currently deployed something or the other, not BCP. But yeah.
Okay. So I have one Michael in the line, which is not me. So let's see if this somehow works.
Hello, can you people hear me?
Yes, we can hear you.
Okay, this is me for the first time using the remote specification thing. So, as authors, we are in favor of making this decision now. So far, feedback from the working group, when we presented this previously, has only been on, I mean, the only type of help that was offered so far has been in terms of helping document what implementations do and what is safe to do and what isn't. So the idea is to give clear practice, clear recommendations about the current practice and what should be done. If we just hand wave about possibilities in an informational RFC, this isn't really helpful, and this isn't really what the working group input would be. So the TBDs that are currently in the document, almost all of them are about what is safe and what isn't safe. And if people are willing to help us in figuring out what is safe and what isn't, then for the working group, it should be BCP. Just, me speaking as a co-author, I think echoing another co-author as well.
Jana Iyengar, Michael, how do you define safe? And this is one of the issues, right? And I fear that this is one of the rat holes. That being able to say that such and such behavior, we can say what's conservative, but
so certain things have been implemented for a very long time. You know, sharing MSS, sharing CartInTue.
Right, but the fact that things are, if these are things that are deployed in operating systems and are used right now, and the internet hasn't actually collapsed, I would say that they're perhaps safe from one point of view.
That's what I mean.
Yeah, they're all safe.
No, not all of them. Sharing SSH isn't necessarily safe. Sharing cVent isn't necessarily safe. That depends on various things. So there's a clear distinction there.
Yeah, okay. We are getting into the rat hole, and that's. But yeah, this is probably a conversation for later. I think the more important one is the first question, anyways, right?
Yeah, I mean, just to be clear, I mean, we can have this conversation afterwards, but still, I'd like to get the sense of the room for my question. We can hold off the status discussion later, but I'd like to get a sense of the room, how much support we have for BCP right now, and I fully understand that this could change throughout the document.
Yeah, I mean, I would say that the conversation around what it is that we recommend, if we keep it a little, if that's not the critical part of the, if it's useful, it's definitely useful to have thoughts that the working group thinks that, you know, maybe this is a good idea and this is not a good idea and so on. It's fine to have that, but I think the useful part of it is the documentation of what actually the current practice is.
Andrew McGregor again. You didn't get to asking the second part of your question, but I actually think that it's the situation. The feeling I'm getting from this conversation is that there is support for publishing the document in some form, and there is little objection to it being a BCP. But that I think we can leave that choice to the authors as to which way they want to push it, unless when you ask the second part of the question, does anybody object to publishing this as a VCP? There's a strong no.
Okay, since we're running out of time, I'd like to raise the two questions, and we will figure out afterwards what exactly we do. We also have to talk to our AD on that one. So the question to the room is, please raise your hands if you think that this can become a BCP. So please raise your hand now. If it can become a BCP. Also, it doesn't mean that you think that the current wording is already BCP, but it can become possibly a BCP. Okay, this is 4 or 5, I would say. 4.5. And please raise your hand if you object, or if you think that there's a huge risk if you would head for a BCP right now. Okay, so there's no significant objection to a BCP. Okay, so on that one, we will have to chat amongst the chairs and probably also our AED. In general, the clear feedback from the room is that there is value in adopting this document, and we will have to figure out the formalism.
Thank you.
Thank you. You can kick me out now.
Done. Okay, so this means we are done with our agenda. So that was the TCPM meeting. See you in Singapore.